Hello and welcome to Knowledge Review number 5. It is time for us to kick back and have a little bit of fun testing your skills with loops. Now we've got 2 challenges set up. The first one's quite simple and the second one requires just a little bit more thought. For those of you that don't have, well, let's just say a logical way of thinking in this world, the second challenge might just be a doozy for you. But hey, that's going to be fun. Okay, so let's go ahead and get started with the first challenge. Now these 2 challenges are related, very heavily related. We're just basically changing out the engine, if you will, from one challenge to the next. You'll see what I mean when we get there. But first of all, what the heck is it that we want you to do? Well, you're going to create a very simple console application. As a matter of fact, Logan, while I'm talking, it might not be a bad idea for me to bring a whiteboard up. You're going to start by asking the user of your application a question. You're going to ask them to enter a number. And then it'll just simply sit here on the next line waiting for them to type in a number. So let's pretend that they type in the number 5. What I want you to do is have echoed back out to the console the following pattern. You start at the number 1. So 1, 2, 3, 4, 5. So there's the high-end number, the number that they entered. 4, 3, 2, 1. Do not print out 0. If they put in a 0, basically what needs to happen is it's just going to turn right around and ask them to enter a number again because we don't want to handle this negatively at the moment. We're keeping this very focused, positive numbers, keep this as simple as possible for this first example. All right, so it is going to turn around. After this point, let's have it simply print out a space right here and ask again for a number to be entered. And we'll put a colon or something. Now let's pretend at this point that they entered a 3. What is going to get echoed out to the console? It'll always start at 1. 1, 2, 3, 2, 1. So in essence, you're always going to start at a value of 1, and you're always going to end at a value of 1. And so if you were to graph this out, what you're going to get, in this particular case, a little triangular type wave here, 1, 2, 3, 2, 1. That's what we're looking for. So you're simply going to count all the way up to the number that they entered. Once again, if they enter a 0 or anything less than a 0, don't worry about it. Just turn around and say enter a number. So if you want to, say enter a number greater than 0 if you'd like. And then there you go. That makes the whole application completely valid. But once you're done, again, you've echoed this out to the console. Now what are we going to do? We're simply going to skip a line to keep it nice and easy to read and turn around with another enter a number. And it'll be sitting there waiting for them to put some sort of value in. Now, obviously, if they put in something like cats, or anything that's not a valid number, like 5xz3, that's not a real number. What needs to happen is the application needs to let the user know that they've entered an invalid number. You can make fun of them, you can do whatever you want. But after you get done having your fun and letting them know that it is an invalid number that they have entered, what do you need to do? Well, for readability's sake, we'll simply space it down and, once again, have it say enter a number. So now you see what we're looking for. We're looking for you to print out this simple sequential set of numbers that are going to work their way from the value of 1 up to the value they entered and then back down to the value of 1. You'll notice that all of this is in sort of a master loop, kind of like a game loop in a way. It's just going to keep running forever and ever and ever, asking for them to enter a number. And once they've entered that number, you'll have your little bit of fun, be it with a real number or some sort of invalid number, and you'll go right back to asking for the next number. So we don't want this to be an infinite loop. So make sure you monitor for the user typing in the word exit. Now, obviously, we don't want to count on the user typing in exit as all lowercase or all uppercase or a small e and a capital X and then a small it or whatever. So make sure you handle that situation appropriately so that the user can type in exit any way they want and it is always valid. But if they type in exit, your application needs to come to an end right then. Okay, it terminates. There is no more enter a numbers presented to them. So that is very, very important. So you have a master loop that is always monitoring for exit and handling, asking the user to enter a number. Now, to pull off this little bit inside, I want you to set up two loops. I'm not looking for nested loops, or am I looking for nested loops? That is always the question of the day. Think about it. Use some logic here. I'm not saying you have to use nested loops, and I'm not saying that you don't have to use them. You do or don't. It's up to you. As long as you give me two loops that handle coming up with 1 all the way up to the number they entered, and then from there all the way back down to a value of 1. Do not double print the number they entered. I don't want to see 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. I don't want to see that, okay? So that is your challenge. This is not difficult. I'm saying this to those of you that might be hyperventilating at the moment, looking for a brown paper bag to grab because logic may not be your forte. That's okay. Give it a shot. Once you've tried to work your way through this, you should once again have 3 different loops in there. And, I've been saying 4 loops, and anytime I say loops, Logan, I just always say 4. They could be do loops, they could be while loops, they could be for loops, Just don't do go-tos, okay? Because that's not cool. Now, once you've worked your way through this and you have an output that is meeting the requirements that I have set forth here, you have solved the problem. If the way you do it and the way Logan does it's completely different, that's okay. As long as you get the output we are requesting and the functionality is exactly as we've specified. But I am looking for, once again, 3 loops in total. So with that, go ahead and get started. Don't stress if this is freaking you out. Just give it a shot. And if you're having a really hard time, come back, unpause the video, or restart it if you've closed it. Zoom forward, fast forward until you get to the part where you see pause now, and then kick back and watch how we go about solving this first challenge. So Logan, with that, let's go ahead and come over here, and we will do 2 things. First thing I want to do is go ahead and kill out all of that, and then come over here and bring up, pause now. So ladies and gentlemen, please, at this time, pause your video. And welcome back. All right. Now, if you never paused the video and you sat there for whatever reason just staring at this red screen waiting for Logan and I to have a conversation about the latest, hottest games that have been released on the market, we are so sorry to disappoint you. Pause the video and do the assignment. And if you have done the assignment and got it to work, congratulations. And if you have not, watch what we do next. It will amaze you. Well, not really, but you get the idea. Logan, let's go ahead and pull up Visual Studio.
All right.
And let's put together this simple solution.
All right. I'm going to begin with a new console application. And inside of this application, we need to do things like get input and then enter it into a loop that puts us into the flow that you had drawn out on the whiteboard. So the key to this entire program is going to be that entered input. And that input I'm actually going to define outside of all of the loops because we need that input to drive the first loop to know if we need to exit or not. So I'm going to define a string called input. Now I'm going to initialize this because we're going to turn right around and check this inside of the loop, so I need it to contain some value other than null. So I'll go ahead and initialize that to an empty string. Now I want to jump down and begin the master loop. For this, I'm going to use a while loop. And inside of this loop, we need to check and see if this input variable contains the value exit. But we need to do this in a case-insensitive manner. So the way I'm going to approach that is to take input, convert it to lowercase, and then compare that against the literal exit, also in lowercase. So our check will be input.toLower is not equal to the string exit. And I'll block that in. So as long as exit is not given as input, then this entire case is true and we continue looping. Alright? So let's begin with the
Well, we've
for
got
this
the.
loop.
Well, let me just jump in. At this point in time, you've got the master loop, kind of like a game loop in a way, structure set up. It's always going to continue looping until the user is tired and ready to exit out. Now, in the loop, looking back to the whiteboard that we had earlier, what did we do? We always, right off the bat, ask them to enter a number. So let's do that. Let's just ask them, enter a number.
All right. To do that, we'll grab our console, and we'll write out a line saying something like, enter a number.
And colon.
And we'll end off the quotes, end off the parentheses. And now we need to actually go and get some input and put it in the input variable.
So we need to do a read line from the console.
So we'll say input is equal to console.readline. And that should wait, give us some input, and store it inside of the input variable. Now, since the way this app works depends on the input being a number, we now need to check that, because in order to work with this, we need to put that value into an actual number, into an integer that we can work with.
That's right, because right now it is just a string.
Right, but in doing so, we have to be careful because the user could have typed cats or something else that's not a number.
That's right.
So we need to be able to handle that case.
And we've all seen how to handle this by doing the try parse functionality.
First, I'll begin by declaring a variable to hold the value provided it is a valid number. I'll call this value or variable value.
Okay.
The next one we'll do is we'll attempt to populate that with the given input. So we're going to do this inside of a check so that we have the ability to handle a case where it didn't work. So inside of an if statement, I'm going to put if int.tryParse. I'll feed it our input variable, and then we'll also say out value, so that if it does indeed, or if it is indeed able to take input and convert it into a number, we can store that out in the value variable. Then it'll finish off the parenthesis for the if statement. So if all this worked, if value or if input could be parsed as a number, we will do whatever is in this block.
Okay.
Otherwise, I'm going to code in an else so that we can handle what would happen if cats or some other invalid number was entered. And for that, all we have to do is simply write out that it was an invalid number. So I'll code that in right here, where we'll do a console write line and simply say invalid number. And after that, I believe you had specified for there to always be a blank new line after each line or each actual output, so that you have what looked like a space.
Now we could, of course, just do write line, quotes, quotes, write line, quotes, quotes, just to push it down, but we're going to
do this all in one line.
Yeah,
so
we'll do it all in one line. A little fancy here.
We'll use a write instead of a write line, but inside of that write, what we're actually going to output is 2 new line characters, like so.
Okay. Good old escape characters. All right, so now that we've got that set up, we're ready to go ahead and, put in our first loop. Now, the way we're going to do this is we're going to use the first loop to allow us to count up to our top in value. So 1, 2, 3, 4, 5 if they enter 5. So let's go ahead and code that in first.
Okay. This is really just a very simple for loop. So I'll begin the for loop. I need an index variable, so I'll define that within this loop as an integer. So we'll have integer I for our index, and let's initialize that to 1, because we know we want to begin at 1, not 0 or some other number. So we begin at 1. We want to continue looping. So here's our condition. We want to continue looping as long as I is less than or equal to the given value. So that means we will reach, if 5 was typed for our value, we will reach 5 because we're going up until it is, as long as it is equal to or less than the value. And finally, for our operation, we want to increment I, so I'll simply do I++. Then we can block in the loop.
Okay, let's go ahead and write that out now.
So inside of this loop, all we really need to do is a write line.
Do a write line, yeah.
Oh, okay, you want to show this a write line first?
Yep.
So we'll do a write line. We want to output I, and we also
just I right now, yeah.
Okay, we want to keep it simple, just I?
Yep. And this gives us, to be honest with you, if you take a look at everything we've got in place right now, we've got a well-structured application that we can run and test out that is going to keep us in a loop until we type exit. It's going to continue asking us to enter a valid number. It's going to verify that the number is valid, and if it is, it's going to count from 1 all the way up to the number. Notice with the way Logan's got this set up right now that if they happen to enter a value that is less than 1, we're simply going to jump out. Because right now we start out by saying I is always going to start out at 1 when we enter this loop. So is 1 less than or equal to value? Well, if value, let's say the user put a 0 into value, is 1 less than or equal to 0? No, it's greater than 0. So we'll simply jump out. That'll be the end. There's no reason to hit the else because we were in the true portion of the if. So we'll write out our extra 2 new line characters and jump back out and ask for them to enter a number. So that is in place, and right now Logan should have it simply writing out 1, 2, 3, however many, all the way up to however many they entered into value, and that is what the right line. Now they're all going to be on separate lines, so that's not what we asked for. We'll fix that in just a second, but I just wanted to demonstrate that with what he's got set up at the moment, if we enter an invalid number, it will come down here and say that we've got an invalid number, give us our 2 new line characters, and then once again ask us to enter a number. So Logan, let's go ahead at this point and build the solution and make sure all works well with no errors, and it does. Now let's go ahead and execute it. All right, enter a number. So let's test it out. Put in 5. And 1, 2, 3, 4, 5, just as we said. Put in 3. So entered 3. 1, 2, 3. So put in 50.
50.
Yeah. All right, so we counted all the way up to 50. So it's working beautifully. Now go ahead and type cats. Invalid number, once again. Enter numbers. Put 1x3. Enter. And, of course, that is an invalid number. And now type the word exit. Enter, and it terminated our application. So our base functionality is in place. First thing is let's go ahead and change that right line to a right and append a simple space after the I so we can separate our numbers. Now let's run it again. Now put a 5 in. 1, and then a space, 2, space, 3, space, 4, space, 5. So there you go. That is the first part of the requirement that we specified. Excellent. So let's go ahead and exit out of this. Now we need to have the second loop that is going to handle the second part, which is going to be 4, 3, 2, 1, or whatever value, and count down to 1.
All right. Let me jump down and begin another for loop. And again, I'm going to use I as our index variable. But instead of starting it at 1, I want to start it at, well, whatever value comes after the typed value in this case. So if the value was 5, we want to begin our loop going back down, so we need to begin at 4. Or rather, we need to begin at whatever the value was minus 1.
That's right.
So we'll start off with I is equal to value minus 1.
Not equals.
Oh, whoops.
All right, there we go.
Value minus 1. And we want to keep looping as long as I is greater than 0.
That's right, because we never want to print out a 0.
And finally, we will decrement I, because we're starting off at a higher value and we want to try to reach 1. And now we just need to write out the value. And this part is exactly the same, so I'm going to copy the output line from the above for loop and simply paste that into this for loop. And now we should be all set.
Okay, so 5. 1, 2, 3, 4, 5, 4, 3, 2, 1. I'll do 3. 1, 2, 3, 2, 1. Beautiful. So give me something bigger. Give me 15. All right, I'm not going to spit it out, but you can see that it's 1 all the way to 15, all the way back down to 1. This is working exactly as we specified. So go ahead and type exit, Logan. Now that is the application that we asked for. At this point, if this was a complete breeze to you, simply move on forward to the next challenge. For those of you that might be having a little bit of difficulty with loops, allow me an extra moment to trace this for you, and I'll do it with a small number to keep things nice and fast. So let's go ahead and jump over here to our whiteboard and bring up a clean sheet of paper that we can use. I call my layers paper. That's funny. All right, so let's go and start out by writing out our 2 loops so that we have just something that we can refer back to. So the first loop was a simple 4, and inside that, Logan had done an int, I equals 1. We continued looping while I was less than or equal to the value entered by the user, and then, of course, we simply incremented by a value of 1. So this is our first loop, and inside this loop, what did we do? We simply wrote out I and a space. Okay? Then we turned around and we had a second loop that handled us counting backwards. So we had a 4, and then inside here, again, we had int, and then an I. And with this, we started it off at value. So this is high end counting backwards. Subtracting 1. And then from there, what did we do? We simply continued doing the loop while I was greater than 0. And we have to walk backwards now because we're counting down towards 0 as opposed to the opposite direction. And once again, we did the exact same thing. We did a write console.write line. Again, my new way of abbreviating. So write I plus a space. So that is what we have. This was the meat of the whole thing, if you will. This is our little engine, our little baby engine. Now, let's go ahead and trace this through. So over on the stack, we had a couple of variables. I'm not going to draw everything out. I'm going to draw everything that's relevant inside of our loops here. We had a value. And then we had this blocked scope variable I that kind of comes into existence and then gets erased and then comes back into existence again. So we'll just write that out like such. Now I'm just going to make a scratch pad right here for me to do some tests. This is where we'll handle all of our evaluations. And then over here, let's throw up a console that we can echo out to so that everybody sees what's happening. All right, very good. So now, let us begin. The program runs and it asks, we're inside the while loop, it asks for the first time to enter a number. And the user happens to enter the number 3. So 3 gets put into value. So let's go ahead and populate value with 3. All right, from there, now that we know we have a valid number, we fall down into our first for loop. So we start out with the initialization of the variable I to a value of 1. So we declare it and we initialize it to the value of 1. The second thing we do when we first begin a for loop is we evaluate. So this is what I'm going to use my scratch pad for here. Is I less than or equal to value? So is 1 less than or equal to value? It currently contains a 3. And lo and behold, the answer is indeed yes. That means yes, run the contents of the loop, which means write out whatever is currently in I, which is the value 1, and a space. So I'll just put some little bitty dots in there to indicate that we've got a space. So the next thing we put out is not going to be butted right up to the value 1 on the console. All right, so now, of course, we've gone over how loops work, so we know the next thing that happens is we come back up here, we increment I from a value of 1 to a value of 2, and we, from there, simply hop over and do the test. Now, I'm not going to continue tracing it that in-depth by redrawing up there. You know where we're going. So now we've got I is a 2, so is 2 less than or equal to 3? Heck yeah, it's less than 3, so what are we going to do? We do the contents of the loop, which means we print out a 2, and a space. Then we jump back up again and we increment the value 2 by 1. So that means it becomes a value of 3. So we jump back over and we evaluate this. Is 3 less than or equal to 3? Well, it's not less than 3, but it is definitely equal to 3. So we write out a 3 and we append a space to the end of it. At that point, we jump back up and we increment I from 3 to a value of 4. We do the next test, which is simply is 4 less than or equal to 3? No, 4 is not less than nor equal to 3. It is greater than 3. So at this point, we are done with the first part of the loop, and we fall down to the second loop. Our focus, if you will, is still right here with the next thing that we write out. Okay? So now, let's put a line here so everybody gets an idea of what's going on. Value doesn't change. Of course, I completely disappeared because of the block scope, but I'm going to leave it there, but just erase its contents. So the first line of this next for statement begins with a declaration and initialization of I, but here's where the fun starts. What do? We take value minus 1. So instead of putting a small number into I, we're going to put a big number into I. So value happens to be 3, so 3 minus 1 gives us 2. So that is what gets put in here to begin with right there. 3 minus 1 is 2. Then we, once again, perform our test to see if we're even going to do the contents of the loop even once. So the question at hand is I, which is a 2, greater than 0? Well, is 2 greater than 0? Yes, it is. So what do? Well, we're going to do the contents of the loop, which is write out I, which is going to be what? I currently contains a 2, and we'll append to it just a simple space. Excellent. Now, once again, we all know that we jump right back up here and we do our operation, which in this case is going to decrement I. So I goes from a 2 to a value of 1. Excellent. So now once again we are going to jump over here and do our test. So is 1 greater than 0? Answer is yes. So we do the contents of the loop, which is print out what is in I at the moment, which happens to be a value of 1. Append to it a space. All right, so now we're going to jump back up and decrement I. So I goes from a 1 to a 0. And then we're going to do the test. So is 0 greater than 0? No, it is equal to 0. So at that point, we are now finished with this loop. And execution continues, which our execution is write a new line. So remember, Logan had the following. So write out a new line and a new line. So the first new line does what? Puts our focus right here. Another new line puts our focus right here, so that we have that one area of space between, the question, enter a number, or the statement, enter a number, and the last stuff that was echoed out on our console. So there you go. That is walking step by step through the entire thing. So if you're having a hard time with loops, I hope by tracing the logic very carefully here, you see how we were able to produce the results that we asked for. And for those of you that may still be watching this and saying to yourself, I know this stuff. Well, first off, I said feel free to fast forward. And to be honest with you, there's no way I could ever give you too many videos because you can always fast forward. So there you go. Hopefully this helped those that's having a hard time with loops and simple logic. Now, let's make it a lot more complicated. Yeah. What I want you to do is the exact same assignment. So actually, Logan, I think this is going to help everyone a whole lot better. Let's go ahead and start off by just erasing everything that we've got right here. Bring this back up. This is for those that happen to fast forward and they're looking for a reference point. So let's come in here and jump in here and jump back up to knowledge review number 5. All right. Second challenge. Take the first challenge and only change those 2 loops. Pull those 2 loops out and replace them with a single loop. That single loop is allowed 1 statement. We're going to make this as challenging as we can. So I'm wanting you to reproduce the same results, 1, 2, 3. As a matter of fact, let's jump back over to whiteboard now because everybody should see that we're now on challenge number 2. So let's go ahead and come in here, and I will get us ready for a pause now because that's coming really soon. Now, we all saw that what we were looking for was for 1, 2, 3, if 3 happens to be the number entered. This is just an example. 2, 1. Okay? So 1, 2, 3, 2, 1. I want this exact outcome from your application if the number 3 was entered, okay? Or the same sequence followed here for whatever number. So if you put a 5, 1, 2, 3, 4, 5, 4, 3, 2, 1. You're only allowed 1 loop inside your master loop. So again, those 2 loops I went over in the last video, the inner 2 for loops, that's the only thing you're pulling those out. Everything else in your entire application stays the same. Now, replace that 1 loop with a loop. It can be, I'll just use a for as example, but you can use a while loop, a do loop, anything you want. So for, the guts of the for, and I don't even want you to use curly braces. Just a single statement. Bet you want to know what this statement right here is, don't you? Okay? So this single statement is going to take care of making 1, 2, 3, 2, 1 possible. Okay? That is your challenge. You're not allowed, so it's not like you can come in here and do a statement and a terminator and another statement and it's all on one line. Well, guess what? The way that the for loop works, it's going to catch you because it's only going to execute 1 statement over and over and over. Then all that other stuff would execute when the for loop was done, because if you don't have opening and closing curly braces, you can't have more than 1 line. So don't forget that. So using only 1 line, reproduce the exact same results that you saw a minute ago. Now, for those of you that have a hard time with logic, if the last video, or not video, but if the last challenge was complex, this one will be a mind bender. Instead of pausing the video, perhaps take a break for a while. ponder about it. Ponder it over. Think about, how do I want this to work? Logic. It's all about logic. The deeper and deeper we get into game design, the more important the logic is going to become. So I've got to start pushing you into a direction where you apply your logical skills. Well, at least you begin to develop your logical skills so that you will have some that you can apply. All right, now that you know what I'm going for, and I'm not trying to demeanor anyone. I just want to point that out because Logan's over here smiling at me. And I guess that is a friendly reminder to, hey, not be harsh. I'm not trying to be harsh. I'm just trying to, point everybody in a direction of reality. Logic's required, isn't it, Logan?
And math.
And math. So, yes, in this particular case, you might want to use some math in your logical thinking. So, with that, let me go ahead and I can leave that right there. I'll just jump over here real fast. And actually, no, I am going to... Well, yeah, it's going to make me want to erase all of that. Just because, dink, there we go. I'll come back to it anyways. Go ahead and pause now, and the best of luck getting this one solved. And if you are a logical thinker, you should be back in about 15 seconds. All right, get going. And welcome back. Hopefully, you flew right through that without any problem. If you had to take a day or two, I understand if you came up with the answer. And if you gave it a day or two and you tried the hardest you could and you still weren't able to come up with an answer, that's okay. Because in this next section, we're going to walk you step by step through a simpler approach in doing this, but you have to think a bit differently. As Logan threw out a second ago, before I had you pause the video, he said math. Well, obviously, with math, there's always a way to get a sequence of numbers out. It's just how are you going to twist the equations into your favor to get that sequence of numbers out. We're asking you to use only one loop here. Ooh, this is going to be fun. So, and for some of you, what I'm about to show might not even make sense until we trace it. And if that's the case, that's okay. As long as at some point you go, oh, they think they're cute. I see what they're doing. Oh, aren't they so neat? Okay? So, here's what I'm looking for. Before, we just used two loops to create the 1, 2, 3, 2, 1. So I'm going to keep drawing this out, and you're going to see why here in just a second. Okay, so we had one loop take care of this, and then we were very easily able to come in here and set up the second loop to do that. Well, we're asking for only one loop this time, so you need to analyze the situation and ask yourself, how can I do, what range would I need to deal with? Well, you're going to need to deal with the range of all numbers possible here, okay? The only thing that's not going to really get in or that we don't want to see is a 0, but we need to look at the whole range of values. So we've got 1, 2, 3, 4, 5. So we need a range of 5 basically because we got 5 numbers we want to get out. So watch this. What if I redrew this? But I drew it like this. So I started out. Now let's pretend that they put in a value 3. That's what they want to count up to and down from. So what if we started out with a 2. So we take the number they enter and we subtract 1 away from it, right? So 2, 1, 0. So this is kind of like, I'm trying to be very careful, so I'm kind of going slow here. I'm looking for the cleanest way to explain this. This is kind of like an inversion of that in a way. Just follow me through here. So 0. Now let's go -1. -2. How many numbers do we have? 1, 2, 3, 4, 5. Okay? How many numbers did we have up top? Let me pull out the pointer and make it a little bit easier to see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Can we come up with this easily?
Yeah,
sure.
very
It's
easily.
just a matter of offsets, isn't it?
All we have to do is change what I starts at and what I ends at, and we can very easily produce that result.
Okay, very good. But now we're dealing with negative numbers here, so that adds a little bit of interest into the whole thing. So this is where we're going to, I don't know, use some new functionality that's available out there. We have shown you that there are math operations available in the foundation for .NET.
We use them in Canon to get to square root.
You got it. Well, if anybody happens to be familiar with basic math functionality, getting the absolute value of a number might come to mind as a possibility if you're dealing with negatives. Because if I got the absolute, what does it do? It always returns the positive value of a number. What's the absolute of 2? Well, the absolute of 2 is 2. What is the absolute of negative 2? Well, it's 2. It's always going to return positive value, okay? So what we need to do is find some way to take this down here and map it into something similar to what we have up there. As a matter of fact, in the end, it needs to be mapped into exactly what we have over there. So how are we going to do that? Well, watch this. Let me just draw it out for you. What if I had a very simple scenario set up that did the following? So if I took the value that was put in and subtract as we work our way down this right here, watch what would happen. Meaning the value entered by the user was a 3. So if I did 3 minus, what was the first number that we had up here? It was a 2, right? So if I did 3 minus 2, if I did, what was the second number that we had up there? So 1. So now if I did 3 minus 1, what was the next number put up there? A 0. 3 minus 0. What's the next number that was put up there? A negative 1. But I want the absolute value of it. So 3 minus 1, the absolute value. Okay? I don't want to deal with these little negatives right here. We want to get rid of them. So what was the final number? It was a negative 2. What's the absolute of that? It'd be 2. So we'd have 3 minus 2. All right, so now that I've drawn this out, let's solve it. What is 3 minus 2? Well, 1. What is 3 minus 1? Well, that'd be a value of 2. What is 3 minus 0? Oh, that's going to be a value of 3. What's 3 minus 1? I just said that a second ago. Is there an echo in the room? It's 2. And finally, what is 3 minus 2? It is going to be a value of 1. Ladies and gentlemen, we have successfully reproduced that. We have more or less mapped this into this by utilizing the value that they entered as our key value we're going to subtract from. Okay, so we've got 1, 2, so 1, 2, 3, 2, 1. Okay, but we've set our single loop up differently because now we're going to start off, like Logan said, we're going to use some offsets in there. We're going to start off from the value and we're going to count backwards, but we're going to start off from the value minus 1. So we start off at 2. So there is a quick overview. Now I'm going to have Logan code it out. After Logan codes it, then we're going to come back in here and I'm going to trace it. For those that are interested in seeing, and for those that aren't, you can just simply stop the video then. So Logan, with that, let's go ahead and jump over now.
All right, back to our console project. And inside of here, the first thing I want to do is rip out the 2 existing loops.
So that's our little mini engine. Okay, so they're gone. So 1 loop, that's all you're allowed.
All right, let's begin our new improved loop. We'll begin a for. We'll start out with an integer I for index. Now, again, we want, like we just talked about with that graph that was going from 2 to negative 2, we want to start out at value, but we want an offset. We want value minus 1.
Okay, right. Now the second one. Let's think about this. We want to go to what? Negative. We want to go 1 less than the value, right?
Right.
So it's in this particular case, we'd really want to go for as long as I was greater than. So as we count our way down, so obviously when I starts off at the very beginning, I is 2, so that needs to be greater than what? Well, this negative number, the negative value, you just can't help but to say it, the negative value. Okay, so if value starts off at something like, well, 3, so as long as I is greater than negative value, meaning negative 3, well, that means we can do negative 1, ching, we can do negative 2, ching, but we can't do negative 3 because negative 3 is equal to negative 3. So this allows you to simply come in here and do as long as I is greater than a negative value. There you go. Hopefully that'll make it easier to throw that in there.
Right. So, I mean, yeah, we've already got that, so let's just drop that into place for our condition. As long as I is greater than negative value. And then you should have the same result that you had just drawn out.
Okay, and now we're just going to walk backwards because, once again, we're starting with the high number and we're working our way to smaller and smaller and smaller numbers. So just I minus minus.
All right.
And for the heck of it, in this, Logan, if you want to just do a quick right line.
Write this directly out. I'll probably just do, let me do this. If I do a right of I, and then we'll add on our
Okay.
So that way we get the number line style drawing.
So let's go ahead and see what we get. And put in a 5?
Let me do a 3.
Yeah, 3. Okay, so
the,
so it matches with what I got on the board. Okay.
So if we put in 3, what do we get?
2, 1, 0, minus 1, minus 2. Are you paying attention? Are you looking closely? 2, 1, 0, minus 1, minus 2. Coming back over to the whiteboard. 2, 1, 0, minus 1, minus 2. Congratulations, ladies and gentlemen. Ching! We have successfully accomplished creating this particular pattern. All right, Logan, go ahead and hop back over. Now that we've proven that we've done it, now let's go ahead and take a look at, throw the absolute in there.
Okay. Instead of just showing I, let's get the absolute of I. To do this, I'll need to jump into the, whoops, I left the app running, so let me go in and exit out of that first. Now we can edit our project, so let's do the absolute, which is held in the math namespace, so math dot absolute, or rather, excuse me, not namespace, but the math object itself. We'll take math dot absolute of I. So let's try that out. We'll enter 3 again, and we get
2, 1, 0, 1, 2. Let me show you what's happening here. So we've managed to basically take, well, if I erase just a little bit right here, this will make it a little easier to see. You know what I'm going to do, right, Logan? I'm just going to show them how we've inverted this, basically.
Yeah, I see where you're going.
The more they see, the better, right? So what we've done is we've now taken this -1 to a +1, and the -2 to a +2. So this is the +1, this is the +2. So now we've got this. We come down, and we go back up. Okay, so now we have an upside down V. All we need to do now is flip it around. Okay? All right, Logan, go ahead and jump back over. I just wanted to demonstrate that that's the pattern they're looking at, 2, 1, 0, 1, 2.
Okay. So let's jump in.
And the program's still running.
Oh, yeah. So we hit the same situation. All right. So then, like you're saying, all that we really have left is to go in and...
Well, at this point, it works. Watch this. This is how easy this is.
See, we're not just flipping it now. If we take that value offset, because you notice right now what we're working with isn't the number range. We're going from 2, 0, and we have 2, where we were supposed to have things like 1, 3, and 1.
Right. So here's what we're going to do. We'll invert it by just simply taking the value and subtracting that result that we were just printing out away from it.
Exactly, because what you had drawn earlier before we even started coding is how you can take the one graph of 2 to -2, and by subtracting value from it, you could get the correct pattern.
That's right. And so now let's do it.
All right, the remaining piece of the puzzle is to simply take value minus the absolute of I. So
okay.
Let's try it out. We'll enter a 3, and look at that.
1, 2, 3, 2, 1.
So now we can try things like 5.
1, 2, 3, 4, 5, 4, 3, 2, 1.
Try 10.
Sweet.
Try 2.
Sweet. All right, and of course, if you try 0,
we still have the ranges set up so that we'll just pretty much skip the whole loop.
There you go. All right, so now, next thing we need to do is trace this out. So I'll go ahead and close this out for you, Logan. Now, we've seen the for loop. It's just this one simple little thing. If you don't mind, again, if you have a complete understanding as to what's going on, feel free to close the video, and congratulations on completing the knowledge review. If you're interested in tracing, stick around. All right, let's jump back over here to the whiteboard. And, lots of stuff. Let's go ahead and just wipe all that out and do just like we did in the last section. Let's write out our for loop. So we'll begin with for, and then in here we had int I. Now this is a little bit tricky this time. We started out with value minus 1. I don't know why I'm saying tricky. I guess I'm saying tricky because it's something other than int I equals 1.
I don't know. Subtraction is pretty tricky.
Yeah, I hear you. Now we're going to continue doing this loop until while I is greater than a negative value. And of course we're walking backwards, so we'll make sure to decrement I by 1 each time we pass through the loop. All right, and then inside here, all we're doing is simply writing out.
I think the one thing I didn't do is I'm pretty sure I've got braces in that.
Oh, do you? Oh, but that's irrelevant. Hang on, ladies and gentlemen, one moment. Take your braces out just to demonstrate.
I didn't think about that until you started drawing it on the board, and I was like, oh yeah, braces.
And it still runs just the same.
So building and running and 5, and all is good. All right.
Okay. So it was just one line in there, so we all know it works. So now what are we going to write out this time? We are going to write out the value minus math.abs, our absolute, which you could have found by simply looking in the help file because you knew that there was math operations available or math methods, so absolute of I, and then of course we'll simply append to it this. Alright, so let's go ahead and we'll close this off so I don't go crazy while I'm drawing this and I continue looking up there. Let's come over here to the stack where we'll draw out some local variables. We of course have value. We're going to have the local variable, the block scope variable, if you will, I. And then I'm going to create myself a giant scratch board that I can do all sorts of operations on. And then once again, I'm going to come over here and draw our console. Are you ready? Let's get going. Alright, so we come down. First thing we're going to do, of course, is ask the user to enter a number. Once they've entered the number, in this particular case, we'll go with 3. We have verified that it is indeed a valid number, and we come down to the for loop, where we begin by doing our declaration and initialization within the initializer portion of the for loop, meaning that the variable I is set to whatever is currently in value, which happens to be the value 3 minus 1, which is equal to 2. A 2 is put in here. That's what all that sums up to, okay? And then what do? Well, we come over here and we say, while I, so what is I? It is 2, is greater than value with a negative in front of it, negative 3. All right. Is 2 greater than a negative 3? Shoot, yeah, I'd rather have $2 than owe somebody $3, okay? So that is true. So we're going to do the contents of the loop where we are going to write out. So I'm going to using my scratch board right here. Value, which happens to be a 3, so we're right here if you happen to be confused, minus the absolute of I. Well, what is I at the moment? I at the moment, ladies and gentlemen, is a value of 2. So 3 minus 2 equals 1, so we're going to write that out with a space appended to the end. So we get our 1, ... Okay? Now that means we're finished with this line, so we come back up here and we decrement from a value of 2 by 1, which will give us 1. Okay? Meaning we subtract 1. So that becomes a 1. Now the next thing we're going to do is come back over here and perform our little operation to make sure we're going to continue the loop. So we evaluate 1 is 1 greater than negative 3. Well, I'd rather have $1 than to owe somebody 3. So the answer is yes, it is indeed greater. So we fall back down to where we're going to take value, so 3, minus the absolute of I, which is a 1 at the moment, which happens to equal a 2. And we're going to print that out with a space appended to it. So a 2 and a space. There's dots there, just hard to see. There you go. We jump back up and we take what is currently in I and we subtract it from a 1 down to a 0, okay? And then we're going to do the same thing. We're going to say, is 0 greater than the contents of value, negate it. So is 0 less than, or greater than, excuse me, a negative 3? The answer is still yes. So that's my yes, and this is my yes. So that means that we're going to fall down to do the contents of the loop, which will once again write out the value of value. So we got 3 minus the absolute of I. So I is 0. So this right here, 3 minus 0, gives us a 3. So we print out the 3 with a space appended to the end of it. We come back up and we now take I and decrement it once more. So it now becomes a negative 1. Okay. Now we're going to say, is negative 1 greater than a negative 3? So I negated whatever is in value. And I'd rather owe you $1, Logan, instead of having to owe you 3. So yeah, negative 1 is indeed greater than negative 3. So yep. So that means we're going to come down to the next line where we will simply say, so we're doing the contents of the loop, value, which is 3, minus the absolute of I. Well, I is a negative 1, but we're getting the absolute of it, so it is a 1. So 3 minus 1 equals a value of 2. So we'll put a 2 up here, and of course we append a space to the end of it. And then, now I'm going to bring my scratch board up here. So I'm just going to do a little wrap around here. So now we come back up and we take our negative 1 in I and we decrement it from negative 1 to a negative 2. And then so we're right here if you happen to be lost at this point. So now we're going to come over here and say, all right, is I, so negative 2, so it's negative 2 greater than a value of a negated 3. So we'll take what's in value, negate it, so we get a negative 3. So negative 2 is indeed greater than a negative 3. So we do the contents of the loop once again, which says take the value of 3 and subtract the absolute of negative 2. Okay, so what do we end up with? Well, we end up with 1 because 3 minus, well, a positive 2 is 1. So we print a 1 and we append to it, dot, dot, dot. So now what are we going to do? Well, we, again, in the loop, we come all the way back up to here, and we're going to decrement I from a negative 2 down to a negative 3. That's what happens when you take 1 away from something that's already negative. And then we simply go back over and we say, all right, well, is I, which is a negative 3, greater than a negated value? Well, value contains 3, so a negative 3. And here we have a problem. The answer is no, because negative 3 is equal to negative 3. And since that is indeed the case, what do? Well, we now jump out of the loop and continue with execution, which happens to append one new line right here, and then another new line right here. So we're ready for enter a new number to go right there. And we have that space in there. So there you go. This traces through the code with everything being done on the scratch pad there, so you can see what happens, and me changing the values being stored in the stack in I as we walk our way through the loop, and finally echoing out what happens to the console as we work our way through it. Okay, Logan, is there anything you want to add to this?
No, I think that pretty much wraps it up. That's a very detailed view on exactly what's happening, because what's happening here is we're getting farther away from the way the brain works and closer to the way math and computers work.
That's right.
And that's what we leverage to make this possible in a single loop with a single statement.
And that does become really important, like I said earlier, as we work our way closer and closer to the world of real game design, where real logic becomes very important. We've got to start thinking this way. We've got to get our students out there to start thinking this way. Don't you agree?
Right. Something moving on the screen generally has to be the result of some equation. You can't have a million if statements dictate everything. That just wouldn't be possible in current bounds thinking, writing, and computers.
That's right. So with that is going to conclude Knowledge Review number 5. I hope you got a lot out of this. If you're still having a bit of trouble with the logic that we presented, let it soak in for an hour. Go grab a Coke or something and, watch TV or something. Come back and watch this again and see if it sinks in a little bit better. I have complete faith that everyone watching this can get it. Some faster than others, but again, it all comes down to how do you think normally on a day-to-day basis? It's time for us to tap into your logical section in your brain. All right, so with that wraps up this video. Thanks a lot.